So for coordinate geometry, essentially what this is all about is more so graphing based questions. So we're coming back to this distance formula, which would have been like briefly introduced in Math 10C, but ultimately it doesn't get a whole lot of love. But just so you know, this is not in your formula sheet. Okay. So you will have to memorize that for the pre-calc exam. So essentially it's saying you need 2 points, and to find the distance between those 2 points, this is how you get it. Okay, let's also highlight this. So as an example here, the distance between point A, which has the coordinates of x and -3, and point B, which is -4 and 2, is 13. Determine x. Okay, so what I'm going to do is I'm just going to start out with the formula, and then we'll sub in later. So square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so my x1 and my y1 I'll label. Same with my x2 and my y2, just to make it easier, because oftentimes where people go wrong is they just get mixed up as to which number should go where. Okay, and they're telling us that the distance between those 2 points is 13, so that's going to be the D. Okay, so x2 is going to be that -4 minus x, that's our x1 squared, plus y2 is 2 plus 3. So I'm going plus 3 even though y1 is -3, because what I'm doing is 2 minus -3 there. Negative times a negative is a positive. That's how I'm getting that. Alright, so actually, you know what I'll do at this point just to start problem solving here? Oop. Let's put that back. So to get rid of the square root, I'm going to square both sides here. So let's get rid of that 13. Okay, so 13 squared, that's going to give us 169. Okay, and now we got that -4 minus x squared plus 2 plus 3 is 5 squared. Okay, fix that. So 5 squared, we know that that is going to be 25. So I'm going to subtract 25 here. So that's going to give us 144 equal to -4 minus x squared. To get rid of a square, I'm going to do the opposite, which is square root. So square root both sides. So I think I'm going to finish this up here. So remember, whenever you square root, you need to consider that you get a positive and a negative answer. So square root of 144 is positive or -12. It's equal to -4 minus x. So because I have two answers over here with the positive and -12, I'm going to just break this up. So I consider the positive answer here on the left-hand side, minus x, and then the negative answer over here on the right. So -12 is equal to -4 minus x. And then solve for x on both sides, or both equations here. So we have 16 is equal to -x. Divide both sides by -1. -16 is equal to x. -12 plus 4, it's going to give us -8. is equal to negative x. Divide both sides by -1. And we get positive 8 is equal to x. Okay, so for this case, we do have two answers for x here that are possible. Moving on to some formulas. So what we're going to do at this point is just review some equations that you guys have already learned about in previous courses. Mostly Math 10C is where this comes from, although you would have practiced some of this in Math 20-1. So for slope-intercept form, that's that y is equal to mx plus b. So m is your slope and b is your y-intercept there. So your y-intercept is where the graph crosses the y-axis. Right? And just to let you know, this is not in the formula sheet. Okay. And as a quick reminder, slope is equal to rise over run. So if you wanted to expand rise over run, that'd be y2 minus y1, x2 minus x1. You need 2 points in order to figure out what your slope is. Okay. And your slope formula also, while I'm thinking about it, will not be on your formula sheet. Okay, that's something you should have memorized. With slope point form, that tends to be a handy formula in this course. Okay, so slope point form, what you need is slope and just 1 point, hence the name. And this is on your formula sheet. So the point you would consider, or the coordinates for the point you're considering, they would go in for the x1 and the y1 spot. They would not go in for the x and y. So just watch out for that. Where you're going to find this on your formula sheet is right at the top right here. It's turned around a little bit, but it's still the same formula. So they just have the slope times x minus x1 on the left-hand side instead of the right-hand side here. All right, and then last but not least is general form. So there's a couple of conditions with writing your equation in general form. A is always going to be positive, and the values in the spots of A, B, and C, they're integers. So what that means is you're not allowed to have any fractions or decimals when you're writing something in general form. Okay, so let's also write a note here. A will be positive. Okay. So sometimes you might get an equation in general form, and general form typically doesn't tell you a whole lot. So it'd be wise to switch it into something like slope-intercept form so that it's a lot easier for you to tell what the slope and what like a point like the y-intercept is. Okay. Other times where general form is used is typically for like after you've found an equation reported in general form. It's typically what tends to happen with this course. So for example here, determine the equation of the straight line that goes through the points C, which is at -6 and 5, and D, which is at 2 and -7. Answer in general form. All right, so I'm just gonna label this for my own sanity: x1, y1, x2, y2. So we're given 2 points. That means we can figure out slope. So that's what I'm going to do first. So slope is equal to y2 minus y1 divided by x2 minus x1. So let's see if I can get this all on the same page here. So y2, that's at negative 7 minus 5, or y1. x2 is 2 minus negative 6. So minus negative 6, same thing as saying plus 6. Okay. So evaluating our numerator, that's going to give us negative 12 over 8. Whenever you have a fraction, you should always simplify it. So this is going to reduce to negative 3 over 2. So I'm just going to put a light blue square around that because that's not a final answer, but important piece of the puzzle here. Okay. So in order to answer in general form, what I recommend that you do is you start with slope point form based off of what we're given. We're given 2 points, so you can choose one of them and then use slope with either one of them. You'll get the same answer. Okay, so use slope point form. To get general form. So again, you can use either point C or point D. Just because I'm going to choose to use point C. So writing out the formula here. And remember, you substitute in for x1 and y1, but not x and y. So y minus 5 is equal to negative 3 over 2. X minus negative 6 is going to give us x plus 6. Now at this point, I'm going to distribute in our fraction. So we have negative 3 over 2x plus, subtract negative 18 over 2, y minus 5. Okay, so what I'm going to do is I'm going to simplify this fraction down in the next step. Y minus 5 is equal to negative 3 over 2x minus 9. And now I'm going to put everything over to the same side and make sure that my x is positive in the process. Okay, so add 3 over 2x and add 9. Gonna have to continue this up here. So we have 3 over 2x plus y plus 4 is equal to 0. And then, as you guys remember, a condition about general form is no fractions allowed. So to get rid of the fraction, I'm going to times this entire equation by 2. So 3 over 2x times by 2, that's just 3x, plus 2 times 1y is just 2y, plus 2 times 4 is 8, equal to 0. All right, as a quick review of slope, so a positive slope looks like an uphill line, so your m will be bigger than 0. 0 slopes, those are going to be a horizontal line, so your equation that you would look out for would be y is equal to whatever number to give you a horizontal line. Okay. With a negative slope, so going to look like a line going downhill. Undefined slopes are vertical lines. So the equation for that you'll see is x is equal to some number c. So we're asked to just roughly sketch out, so it doesn't have to be super accurate here. So I'm noticing that we have a negative slope here, and our y-intercept is 5. So I'm going to write 5, and then I should have gotten a straight line here for this, but I would expect you guys to use a ruler so that you can draw a straight line. We'll see how straight I can draw. Oop. And then we label our graph. Just going to go ahead and create a Cartesian plane here with my x and y axes. So we have x is equal to 6, so that's going to be a vertical line. Oh, that wasn't very straight, but that's okay. With y is equal to -3, that's just going to be a horizontal line below the x-axis. Again, I'm trying to draw as straight as possible, but ideally you'd have a ruler doing this. And then making sure to label your graph. Y is equal to -3. Oh, good Lord. Okay. With this graph, y is equal to 4x. I'm noticing I have a positive slope here, and my y-intercept is at -9. So, good Lord. There we go. So, -9, and it's going to be pretty steep because slope is 4. So we'll go like so. Y is equal to 4x minus 9. So notice how, like especially for those equations like y is equal to -2/7x plus 5 and y is equal to 4x minus 9. So like our examples A and D, I did label like other points where I could, so the y-intercepts at 5 and -9. So just be mindful that when you're asked to do sketches, you should be labeling important points like y-intercepts where you can. Because this says roughly sketch, like perfection is not expected here. Okay. Some important points just regarding parallel and perpendicular lines. So if you have a question referencing parallel lines, you should know that two parallel lines, they will have the same slope. So the slope of one line will be the exact same as the slope of the other line. Okay? When two lines are perpendicular, so that's just a fancy math term, that means that two lines are at 90 degrees to each other. Their slopes will have negative reciprocal slopes. So basically what that means is take the slope of one, flip it, and times it by -1. That's what it means. So for example, determine the equation of the line that is parallel to 5x plus 7y minus 35 is equal to 0. So they gave us it in general form, which isn't too terribly helpful. So we're going to have to adjust this equation here and put it in a more useful form so we can tell what slope is. Okay. This line also goes through point P, which is 2, 9, answer in general form. All right. So, like it says above, we know that a parallel slope means that the slopes will be the same. Okay, so I'm going to want to focus on that 5x plus 7y minus 35 is equal to 0. If I find the slope of that, then I've found the slope of the line we're trying to find the equation to. I need to fix that plus sign there. Okay, so my goal is to get this into y is equal to mx plus b format to find slope. So how I'm going to do that is isolate for y. So minus 5x plus 35. We have 7y is equal to negative 5x plus 35. Divide everything by 7. So we get y is equal to negative 5 over 7x, or negative 5x divided by 7, sorry, plus 5. So this is important, but it's not a final answer. So we know that our slope is equal to negative 5 over 7. And since we were told that these lines are parallel, slope of one line is going to be the same as the slope of our other line. So now that we have slope and we're given a point, we're going to use slope point form. So use slope point formula, I should have said, to determine the general form of equation. So EQT is my shorthand for equation. So the formula for slope point form, I'm going to start off by writing that. I'm going to label the x and y coordinate here, so x1, y1. So y minus 9, because I'm getting it from these coordinates here, is equal to, we found our slope was negative 5 over 7. And then x minus 2. So distribute negative 5 over 7 through. Y minus 9 is equal to negative 5 over 7x minus 10 over 7. And then I want to make sure that my x coefficient is positive, so that's why I'm adding the x term over. Let's add it over here. And then add over the 10 over 7. Oop. Let's reset. Okay. So 5 over 7x plus y minus 9 plus 10 over 7 is equal to 0. Now, a lot of people don't like dealing with fractions, so I'm just going to choose to multiply out the fractions right now, or get rid of the fractions, sorry, by multiplying everything by 7. So we'll have 5x plus 7y minus 63 plus 10 is equal to 0. So we have 5x plus 7y minus 53 is equal to 0. Okay. Last example here. So we're asked to determine the shortest distance between a point at 7, 6 and the line y is equal to negative 2x plus 5. So I always find it helpful to create a little sketchy sketch here. Again, ideally you would do this with a ruler. Okay. So I'm going to draw out this equation. So my y-intercept happens at 5. and we've got a negative slope here. So try to draw this straight as possible here. There's that y is equal to negative 2x plus 5. And we know this point is at 7, 6. Okay, so we know that it's going to be in this first quadrant here. And I'll choose to put it approximately, hang on a second, if it's 7, 6, need it a little bit higher. Approximately there. Okay. So, at this point it doesn't seem like we've got enough information. However, if I draw a little line here, going straight between the point P, maybe I should label that as P, and our y is equal to negative 2x plus 5, notice that this forms a right angle here. Okay, so it's important to know that these are perpendicular. So that one with that one, if we consider this point here along the line here. Okay, so I'm gonna call this point here, which we don't really have that much information for. We're just gonna call that point Q. We have no clue what the x coordinate is, so I'm gonna call that x. We also don't know what the y coordinate is, but we've been given the formula, right? So we can say that, well, we can use the formula to figure out what the y coordinate is once we know our x. Okay, now how we're going to figure this out is by using our slope formula to get us started. So remember, slope is equal to y2 minus y1 divided by x2 minus x1. Okay, so we know, since we're considering this point and this point, okay, that this line here, that dotted light blue line, will be perpendicular to this y is equal to negative 2x plus 5. Okay, so I'm going to take the perpendicular slope of this equation that we're given. Okay, so the perpendicular slope of negative 2, if you flip it and times it by negative 1, it would be 1/2. Okay. Now, you need to choose what you're going to consider as your first point versus your second point. For me, I'm choosing to consider point P the first point just because it was given in the question. There's no other reason why. You could switch which you're talking about as your second point or your first point, and you will get the same answer. Okay, but I'm just labeling here so that it's easy for me to substitute in numbers. Okay, so y2, that's 6 minus negative 2x. Oh, hang on. Did I mix this up? Oh, good lord. Hang on. I gotta fix this. So x1, y1 is at 7, 6. x2, y2 is at x, and negative 2x plus 5. So let's fix this. That's my bad. Alright, so negative 2x plus 5 minus 6. Okay, x2, that's x, minus x1, that's 7. Okay, so at this point, I've got two fractions on either side. I'm going to simplify this one as much as possible. So how I'm going to do that is by combining these two terms before I go ahead. So negative 2x minus 1 over x minus 7. Because I have two fractions on either side of an equal sign, that means I can cross multiply. Okay, so 1 times x minus 7 is still going to be x minus 7. Okay, and then 2 times negative 2x minus 1. I'll just take this stepwise. So that's going to be negative 4x minus 2. Now isolate for x. Plus 4x. Oop. Should move that over a little bit. Plus 7, plus 7. So we'll have 5x is equal to 5. Divide both sides by 5. And we have x is equal to 1. Okay. So that's not a final answer, but we're getting there. Okay, so the whole point is we want to figure out what these coordinates are for point x, so we can figure, for point q, sorry, so that we can figure out what the distance is between point q and point p. That is our goal here. Okay, so we've found the x for point q. Now we need to figure out, okay, what is the y value? Now, since we have the equation, all we need to do is we need to substitute x into this equation to figure out the y coordinate of it. Okay, so maybe I'll just write that as a note, what I said. So we need to find the y at this point. On the equation y is equal to negative 2x plus 5. So let's do that in pink to show it's a different step. So y is equal to negative 2x plus 5. Substitute in 1 for x. Okay, we have negative 2 plus 5 is equal to 3. Okay. So it's an intermediate step, or intermediate answer, I should say. So I'm going to put a light blue box around it. Okay. So because I labeled my q coordinates as x2 and y2, I'm going to sneak that in here. Okay, so x2 and y2. All right. Now, final step here. Maybe I'll do it in green. Now that we have the coordinate of point Q here, we can find the distance between point Q and point P. So now we need that distance formula. So I'll scooch it over here. Distance is equal to the square root x2 minus x1 squared plus y2 minus y1 squared. Okay. So we know our x2 is 1 minus, and then our x1 comes from point P, so that's that 7. Squared plus y2, that's the 3 we just found, minus y1, which is 6 from point P. So 1 minus 7, negative 6 squared, plus negative 3 squared. That'll give us positive 36 and 9, which will give us 45, which you should always answer in the most reduced form. So taking this stepwise, we can go 9 times 5. Square root 9 as we bring it out, so that's 3 square root 5. So that is our distance, which is our final answer.